Hey guys, and welcome to the session. In this video, I want to discuss the difference between equality and identity checking. So what we'll briefly do is cover equality by itself, same for identity, look at a few examples, and then kind of compare and contrast the differences between these two. So to kick things off, let's define a variable. Let's call this variable A and say it's equal to 100. Let's then define variable B and say this is equal to 100 point, I don't know, let's do a load of zeros to begin with. So we have an integer and we have a float here. Now, if somebody was to say to you, is A equal to B? Do they have the same value? Well, yeah, 100 is the same as 100.000. They both have the same value. Imagine if these were weights on a seesaw. Yeah, if one weighed 100 kilograms, the other one weighed 100.0, yeah, it'd be balanced. Those things are equal to each other. So if I was to say A is equal to B, and we go ahead and hit run, we get true. That's absolutely fine, but of course, if we then make A equal to 101, run that again, we get false. So the idea of equality is we don't care where these items live in memory. We don't care kind of what block they're situated in your RAM chip or whatever. We just want to know, are they equal? So maybe I did A is equal to hello, like this. And then let's maybe do something like 5. Then let's try something like len of, let's say len of A equal to B, and we get true, yeah. This will come out as 5, and then 5 is equal to 5. This has the same value as this. So with equality, we just care about, are they balanced? Are they the same thing? Identity, at first glance, can look like it's doing the same thing, but however, there is a key difference. The way to understand this, I think, is to kind of rewind it all the way back, and let's introduce a really simple function which is built in, which is called the ID function here. Let's do ID of A, and in fact, let's do A like this, and we'll put this guy underneath again, and then we'll do the same thing for B, like this. So just before I run it, ID is a built-in function. You can think of it as saying like identity, and if you imagine when we run this code, Python has to somehow store this in memory, and then later on we can say, okay, let's go back to whatever A is. Python is going to store these two things in particular spaces in memory. So if you think of your RAM chip, imagine it having like, let's see, slots like this here. Now, each of these slots is going to have a memory address, and Python knows, basically, okay, this memory address, this is what's in here, this is what's in here. So when we run this, it's going to be storing these in these slots, and later on it's then going to go back into these slots, pull out the value, and so on and so forth. If you imagine like this in a really simple point of view, imagine this has 1, 2, 3. So imagine this was address 1 here, right? Python's going to store effectively each item in its own little slot, and each of those slots will then have its own address. So if we run this code now, we see we get 2 numbers. These numbers basically correspond to its unique address. It's going to be different every time, so every time we run it, we're going to go into new slots in memory. But you can see here, I've run it 3 separate times. And yeah, let's just do the first one, for example. Maybe if we clear the screen, run that again. So we can see our variable A is living in this slot here. Variable B is living in a completely separate slot. Fairly close, yeah, you can see it's 437, 439. But yeah, it's living in a different place in our computer. So imagine that like A is living in here, and we've got some kind of space here, and B is living down there. So Python is choosing to store A at a particular location, and then store B in a separate location much further down our RAM chip, so to speak. So that's all ID is doing. ID is basically saying, where does it live? And you can guarantee that these will be unique during the runtime of your current Python program. Now, identity checking is basically just seeing, is this number the same as this number here? So in this case, we know A and B, they don't live together. They live in separate places. So if I said, let's do, for example, A is B, like this, run this again. No, they're false, of course, because this lives at 433, so on and so forth. This lives at 435, so on and so forth. They are not the same item. A is pointing to one slot in memory. B is pointing to a separate slot in memory. Now let's try something interesting. Let's go 5.0 here. Let's print the following. Let's do A is equal to B, comma, A is B. So we're saying, are they equal? True, false. Are they the same item? Are they pointing to the same thing in memory? We get true, false. This will be a case where two items have the same equality, the same value, but they're not pointing to the same block in memory. So in this case, A is a float, 5.0. You can see where it lives. It ends in an address ending in 6320. B is an integer ending in the address 3224. However, they're equal. If you were to put these weights on a seesaw, that seesaw would be balanced, meaning they have the same value. So, true, they're equal to each other. On the other hand, A is B. No, they live at different places. So that's how two things can be equal without being the same thing. I hope that makes sense. Now, if you're practicing for the first time, I would try running this with a range of different values, printing off the identification or the identifier of those values, and then have a go at setting up something like this. So ask yourself, is the item equal? Kind of work that out by thinking about your seesaw, and then saying, okay, A is B. This will only ever be true if the items live in the same place. So say, for example, if I did B is equal to A, let's quickly remove this, run this again. Because we've said B is equal to A, basically we're saying, okay, now B effectively points to the same block in memory. So that's why A's address ends in 0064. B's address ends in the same place because B is A. So if we now run this again, we should get true and true. Let's hit run. And there we are. Yeah, there we go. We get true. So that's my kind of quick introduction and kind of summary of how I kind of think about equality versus identity. Now, I think equality is something we tend to use more often. And I think with this, it's probably quite straightforward to understand. I always kind of think of it as a seesaw. And it's generally with identity where I think people kind of have the most problems. But I think if you're getting started with this, one of the best things you can do really is just use the ID function, try to become aware of its existence. And if you're kind of stuck as to, okay, are two items, are they the same thing in memory? Just pass them both through the ID function. If those numbers are the same, you're good to go. They both refer to the same block in memory. If those numbers are different, that means that they are kind of distinct, different items. They live in different blocks in memory, so you can treat them as two individual items. One other thing to kind of be aware of, actually, let's just try something real quick. Let's try A is equal to 1, 2, 3, like this. And let's just run those together. Okay, looks good. Now let's try something. Let's do A.append. Let's do 65. And then underneath, let's print off A and print off B. Now, even though I appended to one list here, A, okay, yeah, there we go, printed A, 1, 2, 3, 65. Look at what happened when I printed B, 1, 2, 3, 65. That's because of this here. So even though I appended to one item, this list, right, and imagine like that list exists somewhere, here's its data inside it, A is basically pointing to that. Then because we said B is equal to A, B is also pointing to this, so whatever happens to this list, yeah, A is going to pick that up, but B is also going to pick that up as well, and that's purely because they have the same identity. So in this case, we define A, we say B, you now point to whatever A is, so whatever happens to A, there's like a chain reaction is going to follow. That's why when we appended, in this case, 65 to A, we appended that to A, but B is also aware of that as well. And again, we've proven that with the use of the ID function. So guys, we'll round the video off there. I hope that helps you understand the difference between equality and identity and the kind of nuances between them. If you've got any tips of your own of how to kind of correctly understand both and work out the differences, feel free to ping us a comment. I'd love to hear what you guys think. Cheers.